Solve the equation log base 6x minus 3 plus log base 6x plus 2 is equal to 1 for x is an element of the real number set. So what we're going to do is write the equation as a single log equal to a number. So at the moment we have two logs added together equal to 1, and we just want one log equal to a number. So we're going to use law 1 of logs, which says that log base a, x times y, is equal to log base a, x, plus log base a, y. But we're actually going to use this law in reverse. So going from log base a, x plus log base a, y to log base a, x times y. So this plus is going to come multiply. Now we don't need an actual multiplication sign because we just have two sets of brackets which mean multiply. So log base 6 x minus 3 plus log base 6 x plus 2 becomes log base 6 x minus 3 multiplied by x plus 2, and this is still equal to 1. So we got that from law 1. So next thing we want to do is multiply out these brackets. So I've done that over here. So x minus 3 times x plus 2. I'm going to bring down the x and the minus 3, and both of those are going to be multiplied by x plus 2. So what I have is 2 eggs, and I crack open the first egg. I bring down the x, I bring down the minus 3, and multiply both of them by whatever is in the second egg, which in this case is x plus 2. So then I have x by x is x squared, x by 2 is plus 2x, minus 3 by x is minus 3x, minus 3 by 2 is minus 6. Then the 2x and the minus 3x goes together, and I end up with x squared minus x minus 6. So that's where the x squared minus x minus 6 came from. So I have log base 6 x squared minus x minus 6 is still equal to 1. The next thing I have to do is to write my log in index form. So I'm going to use my scorpion tail method, and I always start with the base, which is the 6. And 6 to the power of 1 is going to be equal to x squared minus x minus 6. So with the scorpion tail method, we always start with the base, which in this case is the 6, and we wrap around the end of our equation past the number that's at the end of the equal sign, which in this case is a 1. That becomes the power. And then we pass over the equal sign, so it's going to be equal to whatever we have here, which in this case is x squared minus x minus 6. So 6 to the power of 1 is equal to x squared minus x minus 6. So let's look at that closely. So 6 to the power of 1 is equal to x squared minus x minus 6. So 6 to the power of 1 is equal to x squared minus x minus 6. So we have x squared minus x minus 6 is equal to 6 to the power of 1, which is just 6. And now what we want to do is get all our x values and all our numbers on the same side so that we can equal it to 0. So I need to bring this 6 to the power 1, which is the same thing as 6, over the other side of the equal sign. So technically I'm minusing 6 to cancel that out. So I'm going to have to minus 6 on the other side as well. So if I bring positive 6 over the equal sign, it becomes minus 6. So I end up with x squared minus x minus 12 is equal to 0. So now I have a quadratic that I'm going to factorize and then solve. Alternatively, I could have used my quadratic formula, or my minus b formula as it's called. So I'm going to factorize x squared minus x minus 12. Since I have an x squared here, I'm going to have an x in the front of both brackets. Since I have a minus here, I'm going to have different signs. And I have 12 here, so the factors of 12 are going to be 1 and 12, 6 and 2, 4 and 3. And I need to choose one of those factor pairs so that I end up with minus 1, because minus x is the same thing as minus 1x. So I'm going to go from minus 4 and plus 3, because minus 4 plus 3 gives me minus 1. So my factors of x squared minus x minus 12 are going to be x minus 4 and x plus 3. I can multiply these out to check, do I get back to my quadratic just to be sure. X by x is x squared, x by 3 is 3x, minus 4 by x is minus 4x, Put them together to get minus 1x, and minus 4 by 3 is minus 12, so yes, I have factorized correctly. Next step is to solve. So I'm going to let what's inside the first set of brackets be equal to 0, so x minus 4 equals 0, so x is equal to positive 4. Then I'm going to let what's in the other set of brackets equal to 0, x plus 3 is equal to 0, so x is equal to minus 3. So I get two values for x, and what I need to do is I need to go back to my original question and the format that my logs are in, and I need to substitute both of those x values in and see will they work out for me, because they might not both work. So I'm going to start off by checking x is equal to 4. So I had log base 6 x minus 3. So if I sub in 4 in place of that x value, I now have log base 6 4 minus 3, and 4 minus 3 is 1. And log base 6 1 will work because this is a positive number inside the brackets. So that's fine, that will work. Now I'm going to check will the x equal to 4 work with the other log. So my other log was log base 6 x plus 2. So I'm going to swap that x again for a 4. So I've got log base 6 4 plus 2, which is log base 6 6. And again, that will work because I have a positive number inside my bracket. Now I'm going to try my minus 3 value. So I'm going to let x equal to minus 3. Again, I'm going to take my first log, which is log base 6x minus 3. I'm swapping that x value for minus 3. So I get log base 6 minus 3 minus 3. And minus 3 minus 3 is minus 6. So that will not work because I can't have a negative inside my bracket. Then I'm also just going to try my log base 6x plus 2. And again, I'm going to swap the x for minus 3. So log base 6 minus 3 plus 2 is going to be log base 6 minus 1. And again, this will not work either because I have a negative inside the bracket. So x equal to minus 3 will not work. The reason is, if we have a negative inside the bracket, we would say it is not defined. But using x equal to 4 does work in both cases with both logs. So our answer is literally just going to be x is equal to 4.